A flat plate is cut in the shape of a square and a square of side 20 cm with an equilateral triangle of 20 cm adjacent to the square. Calculate the distance of the center of mass from the apex of the triangle. So we have something like this. You have something like this attached to a square plate, and everything here is 20 cm, 20 cm, 20 cm, 20 cm. Now this is the apex of the triangle, and since you have the same material, the density will be the same. Since it is a flat plate, I will consider, let's say, it has m mass m per centimeter square. So let's use that as area density. Now, since it is equilateral triangle, we have 60 degrees here, 60 degrees here, and here also. The distance of this place to this place, we can easily get that. It's going to be 20 sine 60. This place will be 20 sine 60 degrees, and we know that sine 60 is root 3 over 2. So we have 20 times root 3 over 2. That is going to give us 10 root 3. So this place is 10 root 3. That is it. And we also know that the distance of the center of gravity or center of mass of a triangle will be 2/3 from this place to this place. So from this place to the CG here is 2 over 3 root 3. 2 over 3, 10 root 3. So I'm going to make a table like this. Triangle. Area. So what will be the area of the triangle? Half base times height. Half base times height. And what does that mean? We have the base to be 20 cm. So we have half times 20 times 10 root 3. So this one. So the area of the triangle is 100 root 3. Area of the triangle is 100 root 3. Area of the square is 20 times 20, and that is 400. Cm squared, please. Cm squared. Now, distance of the CG from apex of triangle. You have said this one is going to be 2 over 3 times the perpendicular height. And what does that give us? 2 over 3 times 10 root 3. So this one will be 20 root 3 over 3. So this is 20 root 3 over 3. Fine. For this one, the distance of the CG from this point to this place is 10. It's going to be half of this 20 centimeters. So the center of gravity of the square from the apex is going to be 10 root 3 plus 10. So we have 10 plus 10 root 3. Now, let us now check the moments of the triangle from the apex, of the square from the apex. Moments about apex. It's going to be the product of this one and this. So 100 times 20 root 3, and this is going to give us 2000. That's going to give us 2000. This one is going to give us, see, this is 10 into 1 plus root 3. So this one is going to give us 4000 into 1 plus root 3. I believe you are getting it now. I multiply this one by this one. So since 10 is common. Now, the total area is going to be 400 plus 100 root 3, and that's going to be 100 into 4 plus root 3. This gives me 400 plus 100 root 3. So that gives me 4 plus root 3 times 100. This one is 2000, this one is 4000 into this. So if I should add it, it will be 6000 plus 4000 root 3. And that will give me 2000 into 3 plus 2 root 3. Now, to find the CG, I'm going to divide the total moment by the total mass, or total area. Area times mass. So since m is common, I'm removing it. So, distance of CG from apex will be equal to total moment over total area. Its mass is the same, density will be the same. So that will give me 2000 into 3 plus 2 root 3 over 1000 into 4 plus root 3. So you can use your knowledge of solve to solve this, or use your calculator straight. So this one is 2000 to 3 plus 2 root 3 over 100 into 4 plus root 3, and at the end of the gives 22.55 as the center of mass from the apex. The hollow metal cylinder has a base of diameter 35 cm and is filled with water to a height of 1 meter and 50 cm. Calculate the distance of the center of gravity from the base in each case if the cylinder has no top. Metal has weight 20 kg per meter square, and this of surface area, and pi equals to 22/7. Now let's look at it. We have a scenario like this, and the water is to the middle or quarter. For ease in our calculation, let us look at it like this. So I'll be able to calculate the. So let's say the first situation, the water is up to 1 meter, and the height of the metal cylinder is 2 meters. The radius, or the diameter, is 35 cm, and that is 0.35 meter. So since everything must be in the SI units, now let's find the area of the cylinder first, so I'll be able to get the mass. For open cylinder, let's find the area of this place so that we can find the mass separately, and the area of this place. For the curved surface area, for curved surface area of cylinder, it's going to be 2 pi r height. Going to be 2 pi r height, and that's going to be 2 times 22/7 times 0.35 over 2 times 2, because the height is 2, and that will give me 0.05. So this is 4 points. No. 2.2 meters squared. So the mass of curved surface area is equal to 20 times 2.2, which is 44 kg. Please, that is the metal weight. Let us now find the area of this place and the mass. Area of cover, but that's only one cover, is pi r squared, and that's going to be 22/7 times 0.35 squared over 2 squared. Yes, and so that's going to give me. So that gives me 0.09625 meters squared. Let's see what the mass is. Mass of cover is going to be 0.09625 times 20, which is 1.925 kilograms. Let's now see the mass of the water. Mass of water is going to be pi r square height times density. And we know density of water is 1000 kilograms per meter cube. So I'm going to have 22/7 times 0.35 squared over 2. 0.35 over 2 squared times 1 times 1000. So, and that gives me that gives me 96.25 kg. So total weight now, our total mass is equal to the sum of this and this. And I now take the moments of each about this base. So the total mass is 142.175 kg. Now I will now take the moments about this base. So you can do that in any form. You can find the moment and then look at where this will give the moment, the total moment. But for me now, for ease, I just taking it about this point. So the Cg for water is going to be 0.5 meters. The Cg for the metal cylinder, the core surface, is going to be 1 meter. And the Cg for the base is 0 because it's about the base I'm taking it. Now, let me take moments about base. And that will be 44 times 1 plus 96.25 times 0.5. It will be equal to this mass times x. 142.175 times x, where x is the center of gravity for the whole body. So, to find x now, I make it the subject of the formula of the equation. So, which means it is 0.65 centimeter from the base. That's for one. Now for the second one, we are now told that the water is filled up to 0.5 centimeter. That is 50 centimeter. 0.5 centimeter. So the other ones are retained, but the mass of the water and the center of gravity of the water will now change. Now let me change it now. So mass of the water, in the second case, mass of water is equal to pi r squared height, which is, I think it should be half of that because it's filled up to the half of this. So it's going to be 96.25 over 2. Because h is the one changing. And that will give me 48.125. So this one has changed now. 48.125. And the total will now change. And the total now, total mass is 94.05 kg. 94.05 kg. Since you have known it now, we are now going to take the moment about the base again. So, moment about the base. Let's take it now. For this, it still retains 44 times 1. For this one, from this place to this place now becomes 0.25 meter. So, and what is the mass? 48.125. 48.125 times 0.25. It will be equal to 94.05 times y. That is the distance it will now add through. The distance it will now add through. The total mass will now add through. So y will be equal to 44 plus 56.03125 divided by 94.05, and that will be equal to 0.5958, approximately 0.6 centimeter from the base. So this one does not really need much explanation since we have done something similar in the initial stage previously. A trapdoor 120 cm by 120 cm is kept horizontal by a string attached to the midpoint of the opposites that contain the hinge. The other end of the string is tied to a point 90 cm vertically above the hinge. If the trapdoor weighs 50 Newton, calculate the tension in the string and the reaction at the hinge. You have a trapdoor like this, and we are told that it is 120 centimeters by 120 centimeters. Which means that this place to this place is 120 centimeters and it is wide, but we don't need that place. And a rope is tied at this point, and it's attached to this point. We are told that this place to this place is 90 centimeters. 90 centimeters. Now, and the weight is 50 Newton. So this is 50 Newton. Then we have to find the tension in this place and the reaction here. We can use moments to calculate this, and we can also draw triangle of forces in equilibrium to calculate it. Let's see how we can go about it. This is 50 Newton. And from this place to this place will be 60 cm. And with this one, we can know something about the trigonometric ratio here. For instance, we can see that the theta here, tan theta, is equal to 90 over 120, which is 3 over 4. At the same time, we can know this place, because this is 90 square plus 120 square. From the ratio, we can see that this place will be 150 cm. So we can work this easily now. Now, let's see. The clockwise moments about hinge. So let's call this place h. Moment about hinge is 0 because of equilibrium, and total force, net force, is equal to 0. Therefore, 50 times 60 is equal to, no, this will be T sine theta, T sine theta times 120. This place to this place. So to make it SI units, so this one will go. Therefore, T sine theta is equal to 50 times 60 over 120, and that is 25. But I told you now, we can find theta, sine theta now. We know tan theta. So sine theta will be this place over this place. So sine theta is equal to 90 over 150, and that is 0.6. So T is equal to 25 over 0.6, and that is going to be 41.666 Newton, approximately 41.7 Newton. So we have been able to find this. Now, you can also get this portion now. Since total R must be equal, for us to find this R, we can easily do it by drawing the triangle, whatever. But Ry must be equal to 50 Newton minus T sine theta. And we have seen that T sine theta is 25. So this place will be 25 Newton. And Rx, please, should be equal to T cos theta. T cos theta. And we can easily find that because we know what cos theta is. Cos theta, 120 over 150, which is 0.8. And that will be equal to 41.7 times 0.8 Newton. So the magnitude of R will be equal to 25 squared plus 41.7 times 0.8 all squared, and then we find the square root. Let me find the magnitude now. So this is the value of R. This is Ry, this is Rx. So that is the value for R. We can also find the direction of R. The direction of R and T. By we have gotten this one. For this one, theta is equal to R tan 3 over 4. So that is 36.87 degrees. And for R now, let's call that one alpha. You can find the value for R. Alpha will be equal to R tan 25 over 41.7 times 0.8. So you can see this is the direction for this, and at the same time they are equal. The direction for this one also is 36.87. You can also do it by drawing the triangle and using Lami's theorem or whatever theorem you want to use. Now you can see, look at it. So with this, I can find theta, and then R must pass through this place. So if I should draw it now, I have 50 Newton. T R and T is 36.87 R is here. So I can now use knowledge of trigonometry to find R. And from this, I know that this place to this place is 60. And this one, since it is similar triangle, this one too will be, if you cut it here, so this one too will be equal to 36.87 degrees. So automatically I'm having isosceles triangle. I can use resolution of vector, or I draw the triangle out straight. Let's see if I draw the triangle out straight, what am I going to have? I'm going to have something like this. 50 will come down here, R will come like this, C will come like this. You can see. So this place, I'm going to have what here? 36.87 degrees. And this one too, 36.87 degrees. Here too, and this is 50. Because this one goes like this, this one goes like this, so 36.87 degrees. So what happens is this, I'm having an isosceles triangle. So this is T, and this is R. So this place will be 25 and R. Since from here, so this one gives me 41.66 meters. You can say it's 41.7. So you can see this one is even faster in this place. So it depends. So with experience, you know which technique to pick. You can also use resolution of vector. You see that this one and this one are equal. So the sine of this one is equal to 2 of this. So almost the same thing as what I just done now. So if I am using resolution of vector for this, look at this. R equals to T. See from the angle. Now, therefore, 2T sine 36.87 is equal to 50. This one is equal to 50. This one to this one, they are equal. So T equals to 50 over 2 sine 36.87 degrees. And you get the same answer. The plane of a kite of mass 6 kg is inclined to the horizon at 60 degrees. The thrust of the air acting normally on the kite acts at a point 25 cm above the center of gravity. And the string is attached at a point 30 cm above the center of gravity. Find the thrust of the air on the kite and the tension in the string. So we have a situation like this. So if this is the kite, and you are told that it's having 60 degrees to your horizon, the thrust of the air acting normally, that is, on the kite acts at a point 25 cm above the center of gravity. Let's see. This is the center of gravity. So from here to here, we have the thrust of course is 25 cm. So here, it's 25 cm. And we are told that the force acts normally like this. So, and we are told that the string is attached at the point 30 centimeters above the center of gravity. That you find the thrust of the air and on the kite and the tension in the string. So let's see. This one too is 30 centimeters from here. So it is 5 centimeters from here. 5 centimeters from that point. So it's 5 here. From here to here. So, and this we are told that it is weighing 6 kilograms. So that is 60 newtons. And we have this one, this thrust. Let's call this one T. And this S. Let's call this one S. Now to solve this, this is the string. Let's call this point A, this point B, and this point C. And let's take the moment about A. Moment about A to be equal to 0 because it's at equilibrium. Therefore, T is acting normally in this direction. So, T times 5 centimeters, T times 5 over 100. The distance of this place to this place. The distance of this place to this place. We are told that this is 60 degrees. So it's going to be 30 cos 60 degrees is equal to 60 times 30 cos 60 degrees. And this one is 30 over 100 because they are in centimeters, please. That's why I'm dividing by 100 to convert them to meters. So this one will cut this, and this one will be 20 here. Therefore, T will be equal to 20 times 18 cos 60 degrees. So here T is the thrust of the air. T thrust of here. And T is equal to 360. And what is called 60 half? And that's going to be 180 Newton. So the thrust of the air is 180 Newton. Now to find the, the force S, we can see that it will be the sum of this one and this one. It will have to balance these two. Let's see. We are told that this is 60 degrees. And this one acts like this. This is 60 degrees. And this one acts like this, perpendicular to 60 degrees. So what is the total here? Everything is 90 degrees. So from here to here, it's going to be 150 degrees. It's going to be 150 degrees. So this place to this place is 150 degrees. Therefore, T is 180 Newton and 30 degrees here. I'm trying to make it easy. So and we have this one here now. This one is 60 Newton, and that one is acting straight down. Since I have been able to get the direction of T, let us now get up. S. Let's see. Where will S go? S will come to something like this. Let's see. So you can see the direction for S now. To balance this one. To balance this one. Therefore, S sine theta will be equal to 180 sine 30 plus minus 60. 180 sine 30 minus 60. And that's going to be 30 Newton. 30 Newton. Let's see what S cos theta will be. S cos theta will be equal to 180 cos 30 degrees. Because it's the only one that has components in this direction. And you can see that that will be 90 root 3 Newton. Therefore, S will be equal to 30 squared plus 90 root 3 squared all roots. And let's see what that one will give us. So you can see S is approximately 159 Newton. You can also find its direction since we know what the vertical and the horizontal components are. So theta is equal to arctan 30 over 90 root 3, and that is 1 over 3 root 3. So that is the direction of S, and you can see if you want to get it to the kite, it will be 11 plus 60. That is 71 degrees to the kite. A wireless area attached to the top of a mast 20 meters high exerts a horizontal force upon it of 600 Newton. The mast is supported by a steel wire running to the ground from a point 6 meters below the top of the mast and inclined at angle 60 degrees to the horizontal. Assuming that the action of the ground on the mast can be regarded as a single force, draw a diagram of the forces acting on the mast and determine the force in the steel wire. So, and from this place to this place, 6 meters. Run to the ground. And we're told it is 60 degrees to the horizontal. 60 degrees. And we're told that this one exerts, this is the area. So it will have horizontal force of 600 Newton here. And the distance from here to here is 20 meters. 20 meters. Now, the moment of this place, about this place, must be counterbalanced by this one to make everything perfect. Therefore, then moment about ground at this place is equal to 0. And total force will be equal to 0. This place, force that will be equal to T sin theta will act here too. T sin theta will act here. That is T sin 60, sorry, T sin 60. And at the same time, we have 600, it will go here. 600 Newton will go here. So that is for this place. But here now, we take the moment about this place. And the moment will be 0. And the clockwise moment will be equal to clockwise moment. So we have 600 times 20 will be equal to, let me make it like this. T cos 60 times 14, because from this place to this place, it will be 20 minus 6. And that will be T cos 60 into 20 minus 6. Therefore, T will be equal to 20 times 600 over 14 cos 60 degrees. And that will give me, so that gives me approximately 1714.3 Newton. So straightforward. A simple model of ammonia molecule, Na3, consists of a pyramid with hydrogen atom at the vertices of the equilateral base and the nitrogen atom at the apex. The NH distance is 0.1 nanometer and the angle between two NH bonds is 108 degrees. Find the center of gravity of the molecule from N atom. Atomic weight H equals to 1.0. N, that is nitrogen, is 14. 1 nanometer is 1 times 10 to the power minus 9 meters. Now let's see what it will be like. We are going to have pyramid and this base is equilateral. I was told that this one is 108 degrees, 108 degrees, and the other one is 108. N at the apex, H here, H here, H here. I was also told that this place to this place is 0.1 nanometer for each. Now, let's find the distances we can find. Let's find the distance of H to H. You can see it is equilateral in this side, and we have 108 degrees. Why don't I break it into 2? I have 54 here, 54 degrees here. So distance HH will be, let me call this place S, and this place is S. This place is 0.1. S, that is distance from H to H over 2. That's S. You can see. So S, from what I can see now, is going to be 0.1 nanometer sine 54. So S is equal to 0.1 sine 54 nanometer. Therefore, H to H is equal to 0.2 sine 54 nanometer. We have got to this side now. Let us now see, because it is equilateral, the base is equilateral now. This base is 60 degrees. 60 degrees. Let us now find, because I'm trying to find the location of the vertex, the perpendicular distance from the base to the vertex. That's what I'm trying to find. Now I have this. I have got to this place now. So what will this place be? This place will be 2s sine 60. Let me call this place B. That is the perpendicular distance, orthogonal distance from H to the base here. So B is equal to 2s sine 60 degrees, which is equal to 0.2 sine 54 sine 60 nanometer. That is the distance from here to here. And we have also established before, maybe by some time, maybe in another lecture, we'll be able to work it further. The distance from this place to the center here, to the CG here, is going to be 2/3 of B. 2/3 of B. So, let me call this place D. D. CG of base is going to be 2/3B, which is equal to 0.2. So D is equal to 2/3 times 0.2 sine 54 sine 60. Now H, that is the height from the base to N, H will now be equal to 0.1 squared minus 2/3 times 0.2 sine 54 sine 60 degrees, all squared roots. Now let me find H, the value of H. Now since I have found H, that is the distance of this place from this place, let me now do it as I did the other one. So it's going to be something like this. N will be here, and all the H will act through this place. See. And what is this one? 3. Here, this one is 14. And the distance I'm looking for is this. So 17 will act through this place. And how do I work it out? Let me take moment about n. Moment about n should be equal to moment about n should be equal to 3 times 0.03568. So all these moments will now be like, I'm going to find a point along this place where the old 17 will act, and it will be like these 3 acting from this end, and it's going to be something like this: x so the 17 will act somewhere here. 17 times x from n. So x will now be equal to 3 times 0.03568 over 17. And what does that give me? It gives me 0.00697 nanometer, approximately 0.0063 nanometer. So that is the distance of the Cg from the nitrogen atom. A uniform rod ABC weighs 50 Newton and length 4 meter rests with one end A on rough ground and is supported by smooth peg at B, where AB equals to 2.5 meter. The peg is 2 meters from the ground. Find reactions at A and at the peg. So we have something like this: A, C, and we are told that there is a smooth peg is supported by a smooth peg at B, where AB is 2.5 meters. From here to here is 2.5. And from here to here is 4.5. Therefore, this place is 1.5. And we are told the peg is 2 meters from the ground. So this place is 2 meters from the ground. But don't forget, it's a uniform rod. So the weight will act at 2 meter mark here. So from here to here will be 2 meters. Fine. So the smooth peg will give perpendicular reaction like this. So this is B. And from this place to this place is the 2.5. We are now asked to find the reactions at A and at the peg. So this place, we have this. Let's call this one T. And let's call this the reaction here R. Call this one T, we call the reaction at that end R. But since we have known this place, we can see that this place is 2, this place is 2.5. If we use Pythagoras, we realize that this place to this place will be 1.5. 1.5 meters. So we have a perpendicular, a right angle triangle here. So if this place is 1.5 for 2.5 meters, what will it be for 2 meters? Let's see. I'm trying to find the distance of this place to this place so that we can take our moments conveniently. Therefore, let's call this place D. D over 1.5 is equal to 2 over 2.5. You understand? It's a similar triangle situation. This place over this place will be equal to this place over this place. Or this place over this place will be equal to this place over this place. That's what I just did. Therefore, D will be equal to 2 times 1.5 over 2.5. Now, let's take moments about A. Moments about A. This is the anti-clockwise and this is the clockwise. So, therefore, the weight is 50 Newton. So 50 times 3 over 2.5, and the anti-clockwise is T. You can see this T is acting perpendicular to this one, so we multiply it straight by 2.5. Therefore, T is going to give us 50 times 3 over 2.5 times 2.5, and that is going to give us, this one is going to give here 20, and this one is going to give us 8. So at the end of the day, T is going to give us 24 Newton. T gives us 24 Newton. Now, we have a situation. This one goes like this. Okay, let's see. R. Our R in the perpendicular direction. Wow. I want to get this. This one here now. The ratio for this one is the same thing as this one. Look at this. This one here will be equal to this angle. And this one here will be equal to 90 minus this. So automatically this one will be equal to this alpha here. Yes, I've got to that. I hope you get my analysis. This angle here will be equal to this angle here. And this angle here will be 90 minus this one. This one too will be 90 minus this one. So this one is equal to this one is equal to this one. So to find R will now be easy for me. Summation of the forces in the x direction is equal to summation of the forces in the y direction is equal to 0. Now, what is the summation of the forces in the y direction? Summation Fy will be equal to 50 minus T cos alpha minus Ry. Let me now find summation Fx. It's going to be T sine alpha minus Rx. So, with this, I can conveniently find my R. Let's see. I've gotten 24. And from this place, what is sine alpha? Sine alpha is equal to 2 over 2.5, which is 0.8. Cos alpha is equal to 0.6. So, I can get Ry now. Ry is equal to 50 minus 24 times 0.6. And that gives me, I find that one, Rx is equal to 24 times 0.8. And let's see what that one gives us. Now, summation Fy has given me this. Summation Fx is this. So I got to sine alpha plus alpha. So Ry is equal to 50 minus 24 times 0.6. That gives 35.6. Rx is 24 times 0.8 this side from here, 19.2. So magnitude of R is square of, using Pythagoras theorem, I'm able to get 40.45 Newton. I can also get the direction of this, of R. Let me call the direction theta. So theta will be equal to R tan Ry over Rx. And that will give me 35 R tan 35.6 divided by 19.2. And that's giving me 61.66 degrees, approximately 61.7 degrees. So you can go through any means and you get your answer. You can even draw your triangle because the forces will be equal and you will get it. Since you have known this angle, you have known this one to be perpendicular to this. So you get everything right. For this, you can draw the diagram. You see, this 50 will meet this one here, and this one will meet at this point. All of them must pass through this point. So with this, you can draw your triangle and get, by the ratio, get the forces. Let's see what it will look like. We have something like this. 50 comes here and goes like this. And we have this angle to be, okay, let me call it alpha. And this one is moving from 2.5 up like this. This place is 0.5. And with this, we can get this place. We know what this angle is. We can get what this angle to will be. This is perpendicular to this place. So this place to the horizontal, we get it. Don't even need that. Okay, since we know this one to be perpendicular here, this angle here, this is 90 minus alpha. So this place will be 90 minus alpha. That one is got to straight. So with this, you can get the distance of this place to this place. You have gotten the angle of this place and this place too. You'll be able to get this angle too. Now let's see how it pan out. So you can use resolution of vectors or you can draw your triangle. So this one, as it is like this, you can have your triangle, this place, and then this R, and this is T. So you're going to have a triangle like this, 1, 2, and 3. So this is 50 Newton, this is R, and this is T. You can easily get the angle T from what we have here. From what we have here, you get your angle T here. Or here. Yes. You can get it from here. And then you get your R. Or you use resolution of vectors by making everything meet here, and your T will go like this, your R will go like this, and your 50 Newton will go like this. You can easily find the angle for this one. Later on, we'll work this one out. So you can use that as your exercise. Or if time permits me later in the future, I will take them one after the other. 5 forces act as shown in the figure and are in equilibrium. Find the forces P and Q. So you know that forces at equilibrium, the net summation is 0. So what are you going to do? You can draw polygon of forces, or you can use resolution of vector. Breaking each force in vector form, or you just use your normal resolution of vector and add each. So I will use normal resolution of vectors. Let's do that one. So for P, along the vertical, summation Fy is equal to 0. So let me find the vertical forces now. Here I'm going to have, because this place is going to be 60, or I can use that 32. So I'm going to have, and up is positive, down is negative, right is positive, left is negative. So I'm going to have it like this. 50. Okay, let me make it like 50 cos 30 plus 20 cos 20 is equal to Q cos 45 plus P. For horizontal direction, this one does not have vertical component at all, and this one does not have horizontal component at all. So I'm going to have 60 plus 50 sine 30 is equal to 20 sine 20 plus Q sine 45 degrees. These are degrees. So if you look at it, from the second one I can easily find Q, and from there I go and get P. So this is going to be 60 plus 25 minus, what is 20 sine 20? 6.84 is equal to Q sine 45 degrees. So Q is equal to 78.16 over sine 45 degrees, and which is equal to 110.53 Newton. That is Q. Now let's find P. I have to substitute Q in this first equation. Therefore, 50 plus 30 plus 20 plus 20 that is 62.095 minus 110.53 cos 45 is equal to P. So P will be minus 16.06 Newton minus. So which means that the direction of P is actually upward. Direction of P is actually upward. So P is 16.06 Newton upward. That is it. And this is the normal direction for Q. A particle mass 0.2 kg is held at rest on an inclined plane of slope 30 degrees to the horizontal by the application of the force P, which is at 60 degrees to the horizontal. Assuming the reaction N of the plane on the particle is normal to the plane, find the magnitude of P and N. You have a situation like this, and this is 30 degrees, and this is the particle here, and we are told that it's held at rest by P, which is 60 degrees to the horizontal, and here we have N, which is perpendicular to this, and this is the weight, 0.2 times 9.81 Newton. That is what we have there, and this one will be 1.962 Newton. That's what we have there. So you can see, let us find the direction of this N. to the horizontal. This place and this place is 30 degrees. And everything here is 90 degrees. So this place will be 90 minus 30. This place will be 60 degrees. So we have a first situation like this. So we have 60 here, 60 here, P, N. That's it. And we have 1.962 Newton here. So P goes here, N goes here. We can use triangle of forces to complete it, or resolution of vector. And just make it like a vector notation. So let's just use our diagram first. So we have something like this. This is the weight, 1.962 Newton. Then this is P, and this will be 60 degrees. This will be 60 degrees. And from here, N goes like this. This is P, this is N. So this place will be 60 degrees, alternate angles. So this one goes like this, 60 degrees. So you can see we have a situation of, so this place is 30 degrees, and this place will be 30 degrees. So we have isosceles triangle situation. Therefore, we can break it into two and use our trigonometric ratios. So this place will be 1.962 over 2. So from here to here, it will be 1.962 over 2. Therefore, P equals to N, which is equal to 1.962 over 2 divided by sine 60 degrees, and which is equal to, so P will be equal to this. .133 Newton. So that's the value for P and N. So if we are to use resolution of vector, we can also do it in this manner. Because it's at equilibrium, the upward force will be equal to downward force. Left force will be right force will be equal to left force. So from here we can see that along the horizontal x-axis, N cos 60 degrees is equal to P cos 60 degrees. Therefore, N equals to P. That one is established. Now, N sine 60 plus P sine 60 is equal to 1.962. But N equals to P. Therefore, 2N sine 60 is equal to 1.962. So N is equal to 1.962 over 2 sine 60 degrees. And we got the same answer like we got the other time. So that one is solved. A particle is started on in the horizontal plane by three forces having magnitude 20 Newton, 30 Newton, and 40 Newton. If the particle is in equilibrium under these forces, find the direction of 20 Newton and 30 Newton forces relative to the 40 Newton force. So we have a particle like this, and on horizontal plane, especially. Okay, let me make it like this. 40 Newton goes like this. And you know to balance this one up. 20 Newton goes like this, and 30 Newton goes like this. We are now asked to find the direction of the 20 Newton and 30 Newton relative to the 40 Newton force. So we have something like this. Let's call this alpha, let's call this beta. We can solve this by drawing a complete triangle, or we'll use resolution of forces. So let's try again by drawing the complete force. So we have something like this. Triangle, sorry, 40. And like this, the 20 will go up like this, and we'll subtend alpha there. And the 30 will come like this. If you look at it, so this place is beta. So this place will be beta. And this is 30, and this is 20. So it's in equilibrium because that's closed now. To find these angles, it will be very easy if you at least start with cosine rule. Now, let me find this beta first, the direction of the 30 Newton force relative to 40. So, to find this beta, I have to say 20 squared is equal to 30 squared plus 40 squared minus 2 into 30 times 40 cos beta. The sum of this one is 400. The sum of this is 2,500. This one is 1,200. So 2,400 cos beta. So I have, at the end of the day, cos beta will be equal to 2100 over 24. Let me call this 3r7, 3r8. So 7 over 8. So beta is r cos 7 over 8. And that will give me this one is 28 points. Oh, then it's 29 at the end of the day, 29 degrees. That's the direction of the 30 Newton force relative to. So for this other one, the direction of 20 Newton, I can now say sine beta over 20 degrees, 20 Newton, sorry, is equal to sine alpha over 30. And I'm trying to find alpha. So sine alpha is equal to 30 sine 29 over 20. Therefore, alpha will be equal to 3 arc sine 3 over 2 sine 29. What does that give me? That is 46.7 degrees. 46.7 degrees. Now, if I want to use resolution of vector, I just resolve along and perpendicular like this. So I have 40 is equal to 20 cos alpha plus 30 cos beta. At the same time, 20 sine alpha is equal to 30 sine beta. In this situation now, I can have it like this. So sine alpha will be equal to 30 over 20 sine beta. So to find it. Okay, let me divide it through by 10. So I have 4 equals to 2 cos alpha plus 3 cos beta. And I know that sine alpha is equal to 1.5 sine beta. Let me bring this one to the side. So I have 4 minus 3 cos beta is equal to 2 cos alpha. 1.5 sine beta is equal to sine alpha. Okay. Let me divide this one 2 by 2. So that will be 2 minus 1.5 cos beta is equal to cos alpha. So let me square this equation. Let me square this equation and add the 2. So I have 2.25 sine square beta is equal to sine square alpha. So on squaring this one and this one gives me this one gives me this. So let me add the 2. This one plus this one is going to give me 4 plus 2.25. You know, sine square beta cos square beta will give me 1 minus 6 cos beta is equal to 1. You can see. So this one now 3 plus, so 5.25 is equal to 6 cos beta. Cos beta is equal to 5.25 over 6. So just like before, I was able to get this and then that's it. So it's straightforward. Depends on you, but when it comes to 3 forces, drawing the diagram is useful. Some when you know the angles, drawing the diagram is faster. 2 cords, length 3 meters and 4 meters respectively, are attached to one end. Are attached at one edge to 2 points 5 meters apart horizontally. The free ends of the cords are joined together to one end of another cord of length 2 meters. So the free end of the latter is joined a small body mass 2 kg, which is being pulled with a horizontal force 15 Newton to the same side as that of the 3 meter cord. Determine the inclination of the 2 meter cord to the vertical and the forces in the vertical and the force in the 3 meter and 4 meter cord. Okay. 2 cords, length 3 meters and 4 meters respectively, are each attached at one end to 2 points 5 meters apart horizontally. 2 cords, length 3 meters and 4 meters respectively, are each attached at one end to 2 points 5 meters apart horizontally. The free ends of the cords are joined together to one end of another cord of length 2 meters. So the free end of the latter is attached a small body mass 2 kg, which is being pulled with a horizontal force 15 Newton to the same side as that of the 3 meter cord. Determine the inclination of the 2 meter cord to the vertical and the forces in the 3 meter and 4 meter cords. Now we have this situation. 2 points apart, and we are told that it is 5 meters. A cord 4 meters and another one 3 meters. They are brought together like this, and they are joined to another one of 2 meters, which carries weight of, so a force of 15 Newton pushes it to this side. So and mass 2 kg. So let's multiply it by 9.81. So we have this equation now. This is the 3 meter chord. This is the 4 meter chord. And this one now, we are going to find this angle. And we'll find this one too, which we can do conveniently. Let's call this one alpha, beta, theta. From this is what gives this place the forces that they will experience. We can find this place is equal to this place, and this one is equal to this one. From our knowledge, we can use any other formula, either sine cosine, but since it is 3, 4, 5, we know it is right angle triangle. So we can easily find our theta, even we can know the trigonometric ratios easily as they are now. So let's see. This place is opposite now, 4 meter, and this place is the hypotenuse. So let's find this angle here. So sine alpha is equal to 4 over 8. No. Oh, beta, sorry, please. Sine beta and sine is equal to 3 over 5. So for this, we have been able to derive what our alpha and beta are. So this place, I can conveniently draw this one. Okay, I can draw this one to be 53.13, and this place is 36.87 degrees. So what we have now is these are the components of force T. These are the components of force T. So we have P1 like this. We have P1, P2, and P2 is like this. P1 is like this, and this is 36.87. This is 53. This is 53.13 degrees. So if we resolve this one as it is now, we have 15 Newton like this, and this one now we have 2 times 9.81, that is 19.62 Newton. Because this one are the components of this one, so let me break it down straight. On solving this one now, what am I going to have? I have broken this T for me here now. I have the situation now. P1 sine 53.13 plus P2 sine 36.87 degrees is equal to 19.62. Now I have P1 plus 53.13 plus 15 is equal to P2 plus 36.87 degrees. So I know what these are now. So this one is 0.8, this one is 0.6. So I have 0.8 P1 plus 0.6 P2 is equal to 19.62. And this one is 0.6 P1 plus 15 is equal to 0.8 P2. That's it. So from here, I just do my simultaneous equation. So I have 0.6 P1 minus 0.8 P2 is equal to minus 15. Okay, let me make that. And from here, if I multiply this one by, let me say 8, and this one by 6, let me see what it will give me. So this one will give me 6.4 P1 plus 4.2 P2 is equal to 19.62 times 8. This one is going to give me 3.6 P1 minus, this 4.8 minus 4.8 P2 is going to give me minus 90. So let me add everything. So this one is going to give me 10 P1, and this one is going to give me, so P1 is equal to this one divided by 10, that's 6.7 Newton. Now to find P2, let me go to this equation. Yes. So I multiply this one by 0.6. So I have 0.6 P1 plus 15 is equal to 0.8 P2. So I have 0.6 times 6.7 plus 15 over 0.8 is equal to P2. And let me see. So P2 is equal to 0.6 times 6.7 plus 15 over 0.8. And that is. So now we also asked to determine the inclination of the 2 meter cord, this one, to the vertical. This is what you're asked to find. And to do that, I know what this place is. The component of this place, I know this one. So, going to this place, let me call it gamma. So, inclination of 2 meter chord to vertical, gamma. I can find that by saying 15 over 2 times 9.81 gamma equals to arctan 15 over 19.62. Yeah, and that will give me. So the inclination of the 2 meter chord to the vertical gamma is arctan 15 over 19.62, and that's 36.4. This is it. This is the angle. Sorry, the inclination is arctan. The inclination of 2 meter chord to the vertical is arctan 15 over 19.62. You remember the force, this one and this one, and that is 37.4 degrees. 37.4 degrees. Four forces: 10 Newton, 0 degrees, 15 Newton, 60 degrees, 20 Newton, 120 degrees, and 30 Newton, 180 degrees act in the horizontal plane on a particle. Determine the resultant of these forces. A. B. What force is required to maintain the particle in equilibrium? So in this case, they are asking for the equilibrium. Now we can draw it to make it easy to see. So we have that's 20, and here this one is 30 Newton. So we are now asked the resultants. We can break it into vector formats and then express everything, add them together. Everything must add to 0. Or you just use resolution of vectors. Probably you can draw polygon of vectors. So for me to do that, I will need the sets and the board. Now, let me find the sum of the forces in the x direction and the sum of the forces in the y direction. So let me get summation fx will be equal to 10, because this is positive, plus 15 cos 60 minus, because you can see 20 cos 60 minus 30. If you look at this one, I'm having minus 20 minus 5 cos 60 degrees. Now summation fy, and what does that give me? This one does not have any components along the y direction. This one too. So this one has, I have 15 sine 60 plus 20 sine 60 degrees. So this one gives me 35 sine 60 degrees. So let me use calculator to get the values of this. So you can see. So R will be square root of summation fy squared plus summation fx squared. So these are the components of R along the x and y direction. So if you look at it, this one is negative and this one is positive. So let me quickly do that. Square plus. So this one is 37.75 Newton. And the direction, this is how it goes. And this one like this. So the resultant is like this. Can you see? The resultant is in this direction. So this one is 22.5 and this one is 30.31. So what the answer I get here, listen, I will subtract it from 180 to get this case. So this one is now going to give me. So theta is, this one is 53.41. So this place will now be 126.59, approximately 126.6 degrees. That is the resultant. So this is R, and the value of R is 37.75 Newton. So we are asked what force is required to maintain the particle in equilibrium. It will be in this direction. This will be the equilibrium, and that will be this one. If you look at it, this place is 90 minus. This one is 36. So this one goes like that, and that will be minus. So if you look at this now, this one and this place will be equal. So the equilibrium for the B side, the force to keep it at equilibrium will be equal to this same value, that is 37.75 Newton, but act in this direction. This place and this place are equal, and I got that one to be 53.41. So it will be minus 53.41 degrees. Or I can say 306.6 degrees. That is the direction for the equilibrium. So you can see very well now. That's the direction for the equilibrium. An airship mass 10,000 kg is tethered by 4 ropes equally disposed around it, and each making an angle of 15 degrees with the vertical. The 4 ropes will thus be on the face of the pole with vertex angle 30 degrees. What is the lift force on the ship if the force in each rope is 20,000 Newton? Hint: resultant vertical force is 0. So let's take this as our airship. It has weight of 10,000 times g, acceleration due to gravity. Let's call that for 9.81 meters per second square. Now, 4 ropes were attached to it, and we are told that the angles each make is 15 degrees, 15 degrees, at the same time 15 degrees. So, they mix and they make this angle. So, we are also told that the force in each is 20 Newton. Now, we have a lift force. So, it will act like this. Up, L, let me call that one L. So total horizontal vertical force upward is equal to vertical force downward. So this one is downward, these ones are downward. So from this, you realize that L, that is lift, L will be equal to sum of the forces downward, and that is 10,000 times 9.81 plus, since these forces are equal and the angle is the same, so I don't need to be writing it over and over, 4 times 20,000, and in this part it will be cos 15 degrees. So L will be equal to 981 plus 80,000 cos 15 degrees, and that will give us. So the answer is 175,374 Newton. You might say 175.4 kilonewton. A particle is moving with constant velocity in a straight line on a smooth horizontal surface under the action of the following forces, which all acts in the horizontal plane: 100 Newton 0 degrees, Q 70 degrees, P 150 degrees, 70 Newton 225 degrees, and 80 Newton 300 degrees. Determine the magnitudes of P and Q. 1. 2. If P and Q are allowed to take up any direction as long as they are mutually perpendicular, find their magnitudes and the directions. If the magnitude of P is to be twice of Q. So first of all, understand that this is forces under equilibrium. This is talking about the first Newton law of motion, inertia. The body is moving in a straight line, and it is moving with constant velocity, no change in direction, and it means that it is in equilibrium. Now let's draw the forces. Let's represent it. You can use vector notation and whatever, but for this purpose, we are still using resolution of vectors. So let's do it like this. Now, this one, 100, you have 100 in this direction. We have Q like this, 70 degrees. We have P, 150 degrees. And then we have 70. Two to 5 degrees. 2 to 5. And we have 80, 300 degrees. So everything like this will be 300 degrees. So for ease, I will represent it in X and Y direction for myself. So I break it like this one. So this one and this one is positive. So this one is 70. If this one is 150, it means that to this place it is 30 degrees. If this one is 2 to 5, it means to this place it is 45 degrees. If this one is 300, it means to this place it is 60 degrees. From our normal trigonometric whatever. So with this, I have 1, 2, 3, 4, 5 forces. 1, 2, 3, 4, 5. Yes. So it's okay now. Now for equilibrium, the x forces will be equal to 0, y forces will be equal to 0. So let's start from there. Equilibrium. summation fx will equal to summation fy, which will equal to 0. Now let us now resolve it to get our this thing. So summation fx will equal to 100 plus q cos 70 degrees plus p plus 80 cos 60 degrees minus p cos 30 degrees minus 70 cos 45 degrees. So this is equal to 0. So at the end of the day, this one gives me this equation and is equal to minus 90.50. Let us now look at the vertical components. Summation fy equals 0, and that is equal to q sine 70 plus p sine 30 minus 70 sine 45 degrees minus 80 sine 60 degrees. So let me work that. So I have this as equation 1, and let me have this one as equation 2. So for ease, let me multiply equation 1 with, since these ones are easy to deduct, with cos. This one is sine 30 and this one is cos 30. So I have q cos 70 degree sine 30 minus p cos 30 degree sine 30 is equal to minus 90.5 sine 30. You see, this one will be q sine 70 cos 30 plus p sine 30 cos 30 is equal to 118.80 cos 30 degrees. So let me add this one and this one. So this is what I have. And at the end of the day, you realize that this sum is equal to sine 100. So I have q sine 100 is equal to 118.080 cos 30 minus 90.5 sine 30 degrees. So from here now, I can find q straight. So the answer is 58.52 Newton. Now to find p, let me see the easiest place. Okay, let me use this equation now to find p. So p will be equal to 118.80 minus q sine 70 degrees over sine 30 degrees. And I know q is 58.52. So p will be equal to, so p is equal to 127.62 Newton. So that's the angle, and that's the value for q and p for question 1. For the second question, all the other ones we take their orientation, but the orientation for q and p changes and their value changes. So we will now show how that one be. Now this one changes to theta, and this one becomes 90 plus theta. Therefore, this will become 180 minus 90 plus theta, which will be equal to 90 minus theta. So you can see this place is 90. That shows that they are complementary angles, this place and this place. So you know what that means. The sine of this place will be the cos of this other place. Now this one retains. So if we add all these forces again, the only thing is that these ones will differ. Now let's look at the y force and the x force now. So in this place now, p we are told is equal to 2q. So q in that direction, q cos theta minus 2q cos 90 minus theta will be equal to minus 90.50. So what do we have now? We have q cos theta minus 2q sin theta is equal to minus 90.50 Newton. Now let's look at this other one, vertical component. Q sin theta plus 2q sin 90 minus theta is equal to 118.80. All the other forces retain their orientation. So we can still break this down further and say q sin theta plus 2q cos theta is equal to 118.80 Newton. So let's make this one 2. Now, to make it positive, let's make this one 2q sin theta minus q cos theta is equal to 90.5 Newton. I multiply this one by minus 1, so that's what I got, so that everything will be positive. Now, for me to end, so I want to remove Q and some other things. Let me do it like this. Equation 3. Let me make it 2, equation 3. So I'm going to have Q sine theta plus 2Q cos theta over 2Q sine theta minus Q cos theta will be equal to 118.80 over 90.5. Now let me factorize very well. Now I can have Q cos theta into tan theta plus 2, yeah, over Q cos theta over 2 tan theta minus 1 is equal to 118.80 over 90.5. You can see that this one cancels this. So this is just simple algebra. So I made this fraction to equal to a. So this tan theta, you can see, remember this one. So tan theta plus 2 is equal to 2a tan theta minus a. Therefore, tan theta is equal to 2 plus a over 2a minus theta. So theta is equal to r tan 2 plus a over 2a minus 1. So let me substitute this in this equation and let's see what theta comes out as. Now, so I'm able to find tan, the direction for Q, using this equation. And the answer is 63.86 degrees. Now let's find the value of Q itself. So I think I can do that from this equation here. Since we have known the direction for Q, and then I apply this here. So Q will be equal to 90.5 divided by 2 sine 63.86 minus cos 63.86. So Q is equal to 66.8 Newton in this instance, and P is equal to 2Q, which is equal to 133.6 Newton. The direction for P is, the direction is equal to 63.86 plus 90, and that will be 153.86 degrees. Q equals 66.8 Newton. Direction 63.86 degrees.